All right, here we are, Unit 2. All right, one of the key things to remember here is, for this section, is to put your little ones on numbers and variables that don't have any. You can even go through ahead of time and just put them all everywhere you don't have a number, an exponent. Like so. So there's the first 4. This will help you remember that you got to take this exponent and multiply it by each of these numbers. So this is going to be -3 to the 4th power. X to the 2 times 4, which is 8, and y to the 5 times 4, which is 20. Now, a few things to remember. Since we first learned how to do this, you've also learned about negative exponents. All right? So a few things that I've been seeing I want to make sure you avoid. First off, this -3 does not move downstairs. It's a negative number. The exponent is a +4. Secondly, the -3 does not mean -3 times 4. It means -3 to the 4th power. -3 times -3, which is 9, times -3, which is -27, times -3 again, which is 81. Now again, you can use your calculator for this. But remember, anytime you are doing any of the calculator with powers, always remember to put your numbers in parentheses. So -3 to the 4th power is going to be 81. And so don't forget to do that if you're using the calculator to double check your work. And then we just have x to the 8th, y to the 20, and we are free and clear. So it's 2 times 1 times 4 times 8. So that's going to be 8 squared, x to the 8th, z to the 16. And then we just simplify the 8 squared is 64, x to the 8th, z to the 16. That's it. All right, so now we got some negatives going on here. So -5 times 1 times -2 times 1 times 7 and times -2. So what we get is -2 to the -5 power, x to the +10, z to the -5, over x to the -35, y to the -10. Now remember, some of you might have wanted to move the x downstairs first and have x squared at the bottom, y squared, well, x squared move down and make x to the 9th if you wanted to. So that would be another option. Because notice right now, you have x on the bottom and x on the top. Doesn't really matter, okay? So I usually like to put, when I know I'm dealing with negative exponents, I like to put my fraction bar to start moving things. So -2 to the 5th power on the bottom. X to the 10th stays, but these 35 are going to move upstairs and add on to make x to the 45. Z is going to move downstairs. Y is going to move upstairs. And that's it, except for we want to make sure we do -2 to the 5th power, which is going to be a negative number this time. -32 z to the 5th. All right? Again, not the only way to do it, just one way. So I'm going to do it the other way on this one, just to model what you could do. Before I distribute the 4, I could simplify. So the 8 of the, I'm going to put my fraction bar. The 8 of the -1 on top is going to move downstairs. Okay? Now, there's a lot going on here. On the bottom, we have a to the 1st and a to the -4. So what do we really have on the bottom? We have a to the -3. Now, if we move that up top, I don't want to do too much at once, so I'm just going to move those 3 up top and move this a1 to the bottom. B4 is going to cancel. That's all there is to that. The 3 is going to stay on the bottom. Okay? I'm going to clean this up a little bit because I don't need a lot of space. Now, before I move on, I need to remember this is all to the 4th power. So now, I'm going to multiply in here, multiply times this 1, multiply times this 1, which will give me a to the 12th, 3 to the 4th, a to the 4th. Now again, where do I have more a's? On the top. How many more? 8 more. And then 3 times 3 is 9, times 3 is 27, times 3 is 81. Again, not the only way to do it, but especially with the b's canceling, it'd be a lot, you're just doing adding more work if you wanted to send this 4 in right away. So 3 is an example of distributing first, then simplifying. 4, I did an example of simplifying first, then distributing. There is not one right way or wrong way. It's what you choose. All right, those are ones there. So multiply, multiply, multiply. So negative 8 to the 2/3. Yes, it's a 3. X to the 2/3. And then y to the 3/4 times 2/3. Now you have two choices here. You can multiply straight across and get 6/12, and then reduce to 1/2. Or cancel the 3's. And 2 goes into 2 once and into 4 twice. Either way, you get 1/2. Now the only thing to do here is to simplify the negative 8. So this denominator tells you cube root of negative 8, which is negative 2. And then squared is positive 4. Again, if you're still not comfortable with that, you have your calculator. Take your negative 8 in parentheses, take it to the power of 2 divided by 3. And there's your answer, 4. Okay, the last one of these, we're going to set a 1/2 in. So 64 to the 1/2, which remember is the same thing as the square root of 64, that's going to be 8. 3/1 times 1/2 is just going to be m to the 3/2. And then n, 2/5 times, sorry, not 3/2, 1/2. 2's cancel, and I get 1/5. So that's 8m to the 3/2, n to the 1/5. Okay, so we have cube roots here. Remember, when you're using your little green sheet for this, or the sheet in your homework packet, make sure you're looking at the 3 line, the cubic line, not square roots. Pay attention. Again, if you have to go through and remind yourself that those are squareds, this is a 4, maybe make a note of that, to pay attention to which line to use. Now, there is no number that goes into 25, and there's no number that goes into 35, so you end up having to multiply this bad boy and get 875. Now, this one does break down to 125 and 7. And remember, it's always cube root. Well, the cube root of 125 is 5, leaving cube root of 7. Now, instead of getting a huge number here, I am going to break this down to 16 and 2 and 102. And remember, yes, these are square roots. So that gives me 4 root 2 times 10 root 2. And remember this right here, we're going to do the outside numbers and the inside numbers. So 4 times 10 is 40, times Root 2 times root 2 is root 4, or just simply 2, which makes 80. All right, 147. Actually, this one you may not know. You just look on your paper. Remember, start high, like 100, and see what goes in 147. Obviously, 100 doesn't. 100, 200. Then 81, that doesn't work. 64 doesn't work. But 49 does. And it's 3 times. So this is going to end up being 7 square root of 3. Now I look at my letters. I have 4 x's. That really means x, 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 x. Remember, whoops, I'm doing squared. So they're going to come out in groups of 2. How many groups of 2 come out? 2 of them. None left inside. 6, I'm sorry, y. That's actually y, y, 2, y, y, another 2, and y, y, another 2. So how many y's, groups of y's come out? 3. And there's no variables left on the inside. Now, if that was x to the 5th, we'd have 3x under the radical. If it was y to the 7th, we'd have a y under the radical. But all of them simplify out. Now, remember, 9. Your brain's going to want to go, oh, 3, but it's not a square root. It's the 4th root. And 18 is not going to break down 9 times 2. All right? So you've got to think about that. You're actually going to have to multiply these and get the 4th root of 164. X1, x12 gives you x13, y the 6th. Now, 164 actually breaks down 81 times I apologize, brain's not working. There's no way 9 times 8, which is 72, is going to end in the 4. This is 162, which is 81 times 2. Okay? Remember, 81 is 3 to the 4th. So, the 81 is going to come out as a 3. So I'll put my 4th root here. Remember, yes, these are our 4th roots. Now, x's, they're going to come out in groups of 4. I'm not going to draw out 13 x's. But one group of 4, 2 groups of 4 would be 8, 3 groups of 4 would be 12. That would be 1x on the inside. Remember, we have a 2 there. Y to 6. 4 of them are going to come out as one group, leaving 2 on the inside. And remember, if you need to, go ahead and draw it out. You know, y is not that bad. 1, 2, 3, 4, 5, 6. 4 come out as one group, 2 stuck inside. And honestly, if you need to write out all 13 of the other one, fine. Go ahead and do it. Okay, cube root. Now, you could look at that and go, hey, 9 goes in 18. But again, that's for square root. We are dealing with cube roots. Pay attention to that. So I'm actually just going to multiply this and get 576 cube root. Now that breaks down 64 and 9. The cube root of 64 is 4. And cube root of 9, which is not 3, because we're not doing square root, we're doing cube root. 343, that actually is a perfect cube. That comes out as a 7. My x's, all my x's are going to come out. Y's, 2 groups of y's come out. But that's going to leave a y on the inside. Z, well, no z's come out. It's stuck alone in there with the y. All right. Now, for this section, remember, we need to simplify first, then join like terms. So 128 breaks down to root 64, root 2. And remember, these are square roots. 72 breaks down to 36 and 2. There's a plus in between. And 48 breaks down to 16 and 3. Now, the first two we're going to join together because they're both root 2s. The third one, no. So the square root of 64 is 8 root 2 plus 6 root 2 plus 4 root 3. Join them together, that makes 14 root 2s plus 4 root 3. That's it. 125, cube root, that is simply 5. Now, I have an x here, x1. Of these 4, 3 are going to come out as one group. But since I already had one group, that's going to give me 5x squared on the outside. What's going to be left inside? Little 3 up there, 1x. Now my minus. The cube root of 8 is 2. The x squared just drops down, and inside I just got that cube root of x. And then 128 is actually going to break down to the cube root of 64 and the cube root of 2. So minus cube root of 64 is 4, and 6 divided by 3 is 2, cube root of 2. The first two again are going to join together because we have 5x squared minus 2x squared, which is 3x squared. They have the same item here, cube root of x, and then the minus 4x squared cube root of 2, which is tempting because it's also x squared. You gotta leave alone because it's not the same. Must be like terms. All right, 32. Remember, we're doing a fourth root. So the fourth root of 32, there isn't one. But the fifth root is 32, so this is going to be 16 and 2. Again, fourth root. And 162 is going to break down to 81 and 2. Which is nice. We're going to have this root 2 to join together with addition. Now, the cube root of 16 is 2. But don't forget you've got this 3 here to multiply by. If you got to remind yourself, bring it down. 3 times 2 is 6. Now the x's. I have 5. 4 are going to come out in one group, leaving on the inside 2x. Sorry, this should be a 4. Now, plus, fourth root of 81 is 3. The fourth root of 2, right there. Now notice I had this x here. That comes down. It multiplies. If you need to draw it, go ahead. And notice I had this x. Now I have like terms. 6x plus 3x is 9x, fourth root of 2x, like terms. And that's my answer. Oh, the conjugate, or good friend, the conjugate. We're going to multiply by the opposite of the denominator, 2 plus root 7. 2 plus root 7. That's a 2, not a 7. All right. So we're going to distribute the 2 right here and here. So that's going to give me 4 plus 2 root 7. Now remember, at the bottom, I just have to go to Florida. Because if I do the inside and outside, they're going to cancel. 2 root 7 minus 2 root 7. So I literally just have to, and remember, this is always going to be a subtraction on the bottom. So 2 times 2 is 4. Root 7 times root 7 is just 7. So that is going to be 4 plus 2 root 7 over negative 3. And yes, if that denominator would have ended up being negative 2 or a negative 4, some even number, we could have reduced all three numbers, but we can't. All right, remember, this is really root 7 over root 5, and we cannot have a denominator with a radical, so we rationalize it. Kind of like the conjugate, except we just need that radical 5. So that's going to be radical 35 simply over 5. Radical 25 becomes 5. 18, conjugate again. 1 minus root 6. 1 minus root 6. Distribute, negative 3 plus, 3 root 6. The bottom, 1 times 1. Always subtraction. 6, whatever's under the radical. So that's going to be a negative 5. So I end up with negative 3 plus 3 root 6 over negative 5. Good to go. Okay, write this in radical form. Notice the x has the exponent, the 7 does not. So I want to show you what is tempting, what is wrong. The whole thing does not go underneath here. Okay? It doesn't. Now, if you cannot remember where the 4 goes and where the 3 goes, like I said, go back to what you know. You know that this is equivalent to this. So, numerator, denominator. But remember, this is a big no-no. Why? Because the 7x is not in parentheses, like on number 20, which we'll get to. It's just the x. The x is the only thing underneath. Here's my numerator, here's my denominator. The 7 is on the outside. Now in 20, I draw my radical and I put my 3y right in there. Okay? Numerator, denominator, finished. Now go in the opposite direction. Again, numerator, denominator. That's it. Okay? So we get the 5. Numerator, denominator. Okay? Okay, let's do this page. Solve. Go back to basics. This is really no different than x plus 9 equals 18. Well, of course it's different, but the strategy to solve is the same. You've got to get the x by itself by subtracting 9. You've got to get the radical by itself by subtracting 9. You can't mess with the 3 or the 21 yet. So you have square root of 21a minus 3 equal to 9. Now, how do we get rid of a square root? Well, we square it. What we do to one side, we do to the other. So that gives me 21a minus 3 equals 81. I'm going to add 3 to both sides and get 84. Then divide by 21, and I get a equals 4. Okay, and I can go back and check my answer. 21 times 4 is 84. Minus 3 is 81. Square root of 81 is 9. Plus 9 is 18. Answer checks out. Again, this is like 2 plus x equals 7. What would I do? Get rid of the 2. Square root of 25p equals 5. Square both sides. This is the square root. That gives me 25p equals 25. Divide by 25, and I get p equals 1. Which, again, I can plug back in here. 1 times 25, square root is 5, plus 2 is 7. I am good to go. Okay, last page, last few. 25. 5 more. All right, so we have this to the 5/4 power. What we want to do is take this to the 4/5 power. Why? Because when we distribute that, we're going to be doing 5/4 times 4/5, which is 1. But if I do that here, I've got to do it over here also. So that gives me p plus 4 alone here. And then 32, the 5th root of 32 is 2, to the 4th power is 16. Again, question on that? Take your handy dandy calculator and take 32 to the, whoopsie, to the 4 divided by 5 power, 16. Now I just subtract 4 and I get p equals 12. Again, I can check that. 12 plus 4 is 16. 4th root is 2. To the 5th power is 32. It works. All right. I got to get to my b. I got to get that by itself. So first I get rid of the 8. It gives me 18 equals 2b to the 3 halves. I have to get rid of the 2 now. I'm trying to get the letter by itself. That gives me 9 equals b to the 3 halves. To undo this, I need to multiply, take this to the 2/3, and this to the 2/3. Now this one, you can't do the cube root of 9. And you get a whole number. So you're actually going to get a decimal here. So 9 to the 2/3 is approximately 4.3267. Unless the instructions say so, I would accept 4.3, 4.33, 4.327. Those will all be rounded correctly. 3 more. Subtract 3. Divide by 3. Yes, that's 3. The opposite of the 1/2 is 2 squared, or 2 over 1. But remember, x to the 1/2 is really the square root. How are we going to do that? Square it. Same thing. We square this side. So x equals 9. Again, plug it in. 9 to the 1/2 is 3, times 3 is 9, plus 3 is 12. It all works out. All right. Square this, square that. We end up with x plus 6 equals x squared. Then move both of these over by subtraction. X squared minus x minus 6 equals 0. Simple guess and check. I need 2 numbers to multiply to give me 6 that differ by 1. Well, that's going to be 3 and 2. I want more negatives, so that's -3, +2. I'm going to set both of these equal to 0. Then I get x equals 3, x equals -2. Now I need to plug these back in. 3 plus 6 is 9. Square root of 9 is 3. That would give me the statement 3 equals 3. Check. Good to go. -2. Well, 6 minus 2 is 4. Square root of 4 is 2. That's awesome. So 2 is equal to -2? No, it's not. This is extraneous. Whoops, too far. Last one. Square both sides. Boom. X squared equals 2x plus 8. Move these over by subtraction. X squared, oops, sorry, minus 2x minus 8 equals 0. Again, I need 2 numbers that multiply give me 8 that differ by 2. Well, that's going to be 4 and 2. I want more negatives. This is going to give me x equals 4, and this is x equals -2. Again, plug them in and check. 2 times 4 is 8, plus 8 is 16. Square root of 8, 16 is 4. 4 equals 4, check. -2 times 2 is -4. 8 minus 4 is 4. Square root of 4 is 2. But 2 is not equal to -2. Nope, extraneous. And that's chapter 2.